Alright. So 9.3 is called solving rational equations. So have you guys noticed that through every single unit that we've gone through, it starts out with graphing the type of functions that we're learning about. And then you go through simplifying the expressions of those things. And the last thing always comes down to solving, the ability to solve those kinds of equations. So we are going to solve the rational equations today. Are you ready? For sure. Okay, so they go through a lot of this is how you do it, and so I'm just going to do my own this is how you do it scenario. So I'm going to just take this little problem right here. Oops. Let's see if that worked. Slide it off to the right. Perfect. We'll call this example number 1. Whoops, let's not use a highlighter. Oh, that won't work well. Okay, so basically when you're solving rational equations, there's kind of two scenarios. There's the scenario where you have two fractions that are set equal to each other, and then there's the scenario where you have a whole bunch of fractions going on, where there's adding and subtracting. Okay, so this one is where we have two fractions set equal to each other. Does anybody know what it's called when you have two fractions that are set equal to each other? Okay, yeah, a ratio. Well, actually, a ratio is just the one side. When you set the two ratios equal to each other, it's called a proportion. Proportion. So do you guys remember working with proportions way back in, I don't know, 6th grade? I don't know when you guys work with fractions. Okay, so let's do a little pre-example with something super easy. So like, let's say you had 2/3 is equal to x over 5. Do you remember how to solve that? Ooh, yeah, we get to use that word cross multiply. Cross multiply. Okay, so do you remember how to cross multiply? Or how it works? Okay, so yeah, you like multiply the numbers are across, and then what do you do with the 2 times 5 and the 3 times x? You set them equal to each other. That's the part everybody forgets. Okay, you just set them equal to each other, and then you have an equation that you can solve. Okay, so you'd be like, oh, well, this is 10, and so to solve for x, I would divide by 3, and so x is 10/3, right? Okay, well, we're going to do the exact same steps to solve this slightly more complicated equation. Okay, so let's do this. So we're going to write out steps. And so these are going to be steps for solving a proportion. Proportion. Step 1. Okay, so my step 1 is to cross multiply. Okay, so when I cross multiply, I'm going to have this 3x plus 7 being multiplied by this 2x plus or minus 10. Okay, so I'm going to have quantities that are being multiplied by each other this time instead of just single numbers. Okay, and then I'm going to set that equal to the x minus 5 being multiplied by the 5x plus 17. Okay, so now the nice thing about this red equation that I just wrote is that I don't have fractions anymore. So how do I go about solving this? Okay, so can we say our second step is going to be distributing or getting rid of parentheses or foiling? So distribute and simplify. Okay, so on the left-hand side, we're going to have 3x times 2x. What's that? 6x squared. And what's 3x times negative 10? And 7 times 2x? 14x. And 7 times negative 10? Negative 70. Okay, and now we're going to do the exact same thing, but now on the right side. So we have x times 5x, 5x squared, x times 17, 17x, negative 5 times 5x, 5x, ooh, and negative 5 times 17. 85, that's what I was going with. Anybody want to concur with us? 85?
Yeah.
Generally, it's wise to concur with Jaden, so. Anybody else? Good?
Not good at mental math.
Okay, so now what I have is a quadratic equation. Okay, so what is always the first step in solving any quadratic equation? Okay, combine like terms and set it equal to 0. Okay, so our next step is we want to set this equal to 0. So I want to pull it to where I have a positive x squared. So I'm going to pull everything to the left-hand side here. So can I just kind of go at this and you guys follow? We'll see how you do. Okay, so first step would be to subtract the 5x squared. So I have 6x squared minus 5x squared, which is x squared. Okay, follow me? Okay, so in the middle term on my x, I have negative 30 plus 14x. How many x's is that? So this is like negative 16 x's. Okay, and on my middle term on the right-hand side, I have 17x minus 25. How many x's is that? Negative 8x. So for me to solve, I would add this 8x over, right? So what's negative 16 plus 8x? Negative 8x, okay. Everybody follow all those x's? Did I do that too fast? That was kind of a lot of simplifying in one step. So the 8x comes from the right-hand side. So who am I talking to? Who asked that question? Oh, I heard a voice, but no eyes. Yeah, so the right-hand side. So when I combined those like terms, it made negative 8x. And then I just added it to my left-hand side. Okay, so for my constant, I'm just going to add this 85 over. Oh, so what's negative 7d plus 85? 15. Okay, so now that it's set equal to 0, what's a method that I could use to solve that quadratic equation? Ooh, box method. That's the first time for today. Could use a box method. I could factor it using easy method or hard method or box method. Or what else could I do? Quadratic formula, synthetic division, complete the square. So there's lots of options. What do you guys want to do? Probably the one that starts with easy. That's the one I'm going to go with. What two numbers multiply to 15 and add to negative 8? So negative 5 and negative 3. So what are the two solutions that I end up with? 5 and 3. Now, before I decide that these are in fact solutions, I need to go back to the original one and say, what are the values that x cannot be? Okay, so if you go back and look at the original, I have x minus 5. So what's the value that x cannot be? Did I get 5 as a solution? I did. Okay, so does anybody know what that's called when you get a solution by solving, but if you plug it back into the original one, it doesn't work? It's the idea of a whole, yeah, except for you're solving equations as opposed to graphing. This is called an extraneous solution.
Why does work?
Because it's a solution that you get when you solve. You needed a name, it sounds cool. Okay, so 5 is an extraneous solution, so we cancel it out. What about 2x minus 10? What would, that one's also 5 too. Weird. Okay. An extraneous solution is a solution that we get by solving, but if you plug it back into the original equation, it doesn't work. So it's possible that it's not just undefined, but it just not work. Okay, so your solution is just 3 for this. Okay, so how did we do on that scenario? So I kind of lost my steps over here. So after we did step 2, we just kind of solved. And it kind of depends on the scenario. Sometimes you get quadratic pieces and sometimes you get linear pieces that are super nice. So it doesn't always involve solving quadratics. Do I need to do another example of solving a proportion? Yes? Anybody say yes? I saw all no's. One more? Okay, let's do one more. Yeah, it's the same. I mean, it can be slightly different. What's that? What did you? Will it be linear? I don't remember. I think no. I think this one comes out quadratic also. Okay, so let's try this one just really fast. What's my first step? Cross multiply. So would everybody agree that I have 8 times the quantity of x plus 6, and that will equal x plus 3 times the quantity of x plus 1. Okay, so that's cross multiplication. Everybody okay there? Okay, now what? Distribute. Okay, so I'm distribute that 8, so I have 8x plus 8 times 6 is 48. If I FOIL on the right hand side, I have x times x, which is x squared, plus x, plus 3x plus, how about 3 times 1 makes 3 today? It's alright, people make mistakes, I do too.
So bad at adding. So bad at it.
Okay, so I got a quadratic. What do I do?
Simplify equals 0.
Okay, simplify. I need it set equal to 0 to solve a quadratic. So my x squared term is positive on the right, so I'm going to pull everything to the right hand side. Okay, so I'm going to subtract this 8x over, and I'm also going to subtract the 48. Okay, so this will give me 0 is equal to x squared. Okay, well, how many x's am I going to have? So I have x plus 3 is 4x. 4x minus 8x is negative 4x. Good. And then my constant, 3 minus 48, negative 45. Okay, so now I need a method to solve this quadratic. What do you want to go with? Easy method? Somebody say something different. You guys are all kind of whispering, like. Yeah, okay, so the two numbers to multiply to negative 45 and add to negative 4 are negative 9, positive 5. So the two possible solutions are 9 and negative 5. But if I go back to the original, what are the two values that x cannot be? Negative 3 and negative 6. So do I need to worry about negative 3 and negative 6? Nope. So 2 solutions for this scenario. Okay, awesome on proportions? Super. Okay, so we are going to go back up here. Let's see, we're going to solve this one. So this one is a little bit more complicated in the fact that we have 3 fractions this time. Yay! Yeah, so the idea is that now we're adding fractions, right? So this is example 3. Okay, so if we are adding fractions at all, what do we need to have? A common denominator, okay? So now what I'm going to do that's a little bit different is that I am going to get a common denominator for all 3 fractions. I want everything to have the same denominator. Okay, so what is my common denominator for all 3 pieces?
X minus 14.
2 and x minus 7. I'm going to keep it factored. Okay. So, my first fraction only has x minus 7, so what do I need to multiply by? 2. So I'm going to multiply my first one by 2. What does the second one need? and x minus 7. And my third one needs the 2. Oh, I didn't start writing steps. Do you guys want me to write steps for this scenario? Yes? Okay, so sorry. We'll call this non-proportions. Non-props. You write it out. I abbreviate. Okay, so what was the first step that we just did? Find the common denominator. And let's say find common denominator for all fractions. Okay. Do I need to say a second step and then like get the common denominator on all fractions, or are we okay with that? Probably don't need to say that yet, right? Okay, what do I do now then if I'm solving this? Okay, what was the step that I did when I was just adding fractions? What was my second step for adding fractions? Okay, so kind of, yeah, like simplify each piece, right? Okay, so my second step is going to be simplify each fraction. We're not going to squeeze them together yet. We're just going to make it easier. Okay, so on my first fraction, I have a 2 that I have to distribute through the 2x minus 9. So I would have 4x minus 18 over 2 and x minus 7. Okay, on the second term, I'm going to distribute the x through. So I'd have x squared minus 7x over my common denominator. And on the third one, I have 5 times 2 on the top, so that's 10 over that common denominator. Okay, good there? Okay, so I'm going to do a little side note. You don't have to write this down, but I'm just going to explain my next step. Okay, so I'm going to move out of here really quick. Okay, so remember going back to when you were learning about proportions and whatever, and you looked at this and they give you, let's say, 2/13 is equal to x/13. What can you immediately conclude? What's the value of x? 2. How do you know that it's 2 without really doing your cross multiplication? How can I just go straight to the tops are equal to each other? Because the bottoms are the same, right? So I can kind of basically say, I don't need those bottoms, and I can just say that 2 is equal to x. Well, that was cool how that erased. Okay, so that's the exact same step that I'm going to take for this more complicated equation. My next step, once I have all common denominators, is that I can cancel those denominators out. The tops are equal to each other. Okay, so let's write that as our step, third step. So third step would be cancel denominators with an exclamation mark, because that was super awesome. Yes? You can do it that way, and essentially it is exactly the same thing as cross multiplying. Because if you think about it, to get the common denominator, you have to multiply the two pieces together, which it ends up looking exactly like cross multiplication. But you can think of it as I'm just getting the common denominator and cancel out the bottoms. It'll look exactly the same to my eye, whether you're thinking about it differently or not. Okay, so now what we have is we have 4x minus 18 plus x squared minus 7x, and that's going to be equal to 10. Ooh, by the way, so I noticed in the last class, okay, they had some where there was a subtraction sign in the middle. Okay, you know what I'm saying by this? So this sign was a minus. Okay, so what you want to do is you want to just make sure to distribute this minus to both terms following. Okay, so if this was a minus, it would be minus x squared plus 7x. Okay, so be really careful. A lot of people made that mistake on the assignment today. Okay, right now I have a quadratic. What do I do next? Set it equal to 0. So I'm going to pull it to the left side. So I have x squared. Let's see, what's my x is going to be? I have 4x minus 7x minus 3x. And I'll subtract this 10 over. So my constant is going to be negative 28. Okay. So, gosh, I just love it when we can use an easy method every time. What two numbers multiply to negative 28 and add to negative 3? Negative 7, positive 4. There it goes. So, two possible solutions. 7 and negative 4. So, if I go back to the original equation, what is the one value that x cannot be? 7. Did I get 7? Dang it. So 7 is an extraneous solution, which means only 4 is my one solution. Do we want another one of these, or how do we feel? You ready for the assignment? Yeah. One more example? Come on, everybody always is ready for the assignment. Okay, so I didn't show you this because technically I've showed this to you before when we did quadratics. Do you remember? Clearly you do. Okay, so we're going to ignore the idea of the table. So just cross your tables out. We're just going to go straight to just how do you solve equations graphically. Okay. So what you're going to do is you're going to pull out your graphing utility. I'm going to use Desmos because Desmos is super awesome. You can use your calculator if you want. Okay, but what I'm going to do is see how I have two different sides of this equation. There are two different equations. So I'm going to type x over x plus 4 into my y1 and then negative 3 into my y2. Okay, now when you do this on Desmos, I guess I just did this in the last class. So there's my x plus 4. You can't just write negative 3 in Desmos. You have to say y equals. I don't know why, but if it's a constant for some reason, you just need to have a... Yeah, I guess. Yeah. So, there you go. Can you guys see that all right? So my straight line is that flat one, and then I have my hourglass. So what do you think we're looking for? Where it crosses, okay? So the whole idea is where do these two graphs intersect? So they intersect at what's your x value? Negative 3. Okay, so we don't care about the y value, we only care about the x. So to draw this on your paper, you're going to draw the two equations. So we have horizontal asymptote at 1, vertical at negative 4, so it crosses. I hate how they went by 2's here. That was not cool. They're like, let's make this even more complicated and go by 2's. So this does have a horizontal asymptote at 1. You guys remember how to find horizontal asymptotes? Okay, so remember that's where you look at the exponents and decide is it bigger on the top or bigger on the bottom. And for this one, they're both linear, so you use the coefficients that's in front. So that's 1 over 1. Okay, and then you draw your horizontal line at negative 3. Right there, that's perfect. Oh my gosh, I'm so good at drawing. And so they intersect right there, bam, at that spot, at the x value of negative 3. So do realize you're only looking at the x value. You're solving for x, not y. So are you okay to do number 2 on your own? Okay. Anybody else love Desmos as much as me yet? It's pretty amazing. Okay,